Hello everyone, welcome to SAT practice test number 1. This is section 3, the no calculator section. Today I will be walking you through all 20 questions and pointing out some tips and tricks along the way, identifying types of questions, and hopefully this will help you guys out, prepare for your SATs coming up soon. And so we'll begin with number 1. So we have if x minus 1 divided by 3 equals k and k equals 3, what's the value of x? Well, whenever I'm given any sort of equation, I like to write it out. And then they tell us that k equals 3. So we can simply substitute 3 for k. So we get x minus 1 divided by 3 equals 3. Multiply by 3 on both sides to get rid of that fraction. The 3's cancel out. We have x minus 1 equals 9. Add 1 to both sides, we get x equals 10, and 1 is D. Number 2, for I equals the square root of negative 1, what is the sum 7 plus 3i plus negative 8 plus 9i? So whenever you see a number in this form, a plus bi, this is what's called a complex number. It has a real component, the a, and a non-real component, the b, or the bi. And so, since we're adding together these two sets of complex numbers, you simply add you can think of it as adding like terms. So you add the 7 and the negative 8, is negative 1, and then you add the 3i and the 9i. 3i plus 9i equals 12i. So negative 1 plus 12i, 2 is A. Number 3, on Saturday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? Well, so Armand sent M text messages each hour for 5 hours. So 5 hours times the number of messages he sent is how many messages that Armand sent. And then for Tyrone, 4 hours times the number of messages he sent for each hour, which is P, is the number that he sent in total. So we can add these two values together, these two terms together, and we get 5m plus 4p. This question is simply testing association of numbers and their variables. And so since the 5 went with the m in the description and the 4 went with the p, that's another way of thinking about it. Okay, number 4. Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of the value 108 in this equation? So the SAT loves asking these types of questions. You most likely will see a question that gives you a sort of real life scenario that follows an equation, and then you're asked to identify what one of the values means, and usually it's the initial condition. So usually it's the initial like the height of a tree, the height that someone jumps off of a diving board. And so in this case we can see that 108 does not have a variable attached to it. And so that means that that term cannot change. So it's not a rate, which immediately eliminates choices C and D. And then since P is the number of phones left and D is the number of days that she has worked that week, if she has worked 0 days, D equals 0, that means that P equals 108 minus 0, or just 108, which means that she has not worked any days, and so that's the number of phones that she starts out with each week, or her initial condition. So that means that 4 is B. Number 5, we have x squared y minus 3y squared plus 5xy squared minus negative x squared y plus 3xy squared minus 3y squared. And so since this is minus all of the terms in the parentheses, I like to distribute the negative sign, leaving us with x squared y minus 3y squared plus 5xy squared. And now we have negative times negative x squared y, so that's plus x squared y minus 3xy squared and plus 3y squared. So looking at these terms, we have to see if any of them cancel out or add together. So we're going to combine like terms. I see a minus 3y squared and a plus 3y squared. So those two terms cancel each other out. I see x squared y and an x squared y. So that's a 2x squared y. And immediately I can see that choices A and B don't make sense because they have, there's no x squared y squared term. And it's only 2x squared y, not 8x squared y. Or sorry, 8xy squared. And what we have is 5xy squared minus 3xy squared, which is a plus 2x y squared. B didn't make sense rather because we had no more y squared term. Okay, so after combining like terms, this is what we're left with. So the answer is C. Number 6, a pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age a in years, between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? So we're trying to determine the increase in height of a boy's, or increase h, which is the boy's height each year. And so how we can do that is by increasing the age, because h equals 3a plus 26 as the given equation for this problem. So let's just say, for example, and this is always something good to do, plugging in numbers just to simplify and to clear up any confusion in the given equation. If the boy's age, let's say he's 1, that means that h, or height, equals 3 times 1 plus 28.6. 28.6 plus 3 is 31.6. Well, what if the boy was 2 years old? Now we have a equals 2. Well, h equals 3 times 2 plus 28.6. Now it's 6 plus 28.6, or 34.6. Now, the difference between 34.6 and 31.6 is 3. So that means that the estimated increase in inches of the boy's height each year is 3. Or you could have simply looked at your equation, seen that the only term that has a variable is 3a, is a rate. So 3 inches is the answer. Number 7, the formula above gives the monthly payment M needed to pay off a loan of P dollars at an R% annual interest over N months. Which of the following gives P in terms of M, R, and N? And so you can think of in terms of as saying equal to. So P is equal to M, R, and N. Although this equation looks very confusing, very difficult, very tricky looking, all the question wants us to do is simply rewrite and re-scramble this algebraic equation. And so how they want us to do that is by making P equal to everything. So P equals everything, which means we have to start manipulating the equation. And so how can we do that? Well, you see that M equals this entire section right here times p. So p times this whole giant section equals m. Well, when we solve for variables, for example, m equals 4p. Let's just say this is 4, right? This whole section here equals 4, so it's easier to work with. If I want to isolate p, I'll simply divide by 4 on both sides. Now we have m over 4 equals p. And so what we can do here is imagine that we're dividing both sides by this giant portion of the algebraic equation. And so I can just make some room for myself down here. So it'll be m divided by this giant algebraic portion. And so from that, we can deduce that it can't be c, and it can't be d because they simply don't have enough. It's obvious that we're going to have either a or b. And so when you divide by something, for example, you can go back to that previous example of m equals 4p. When we divided by 4 ended up now on the bottom, on the other side of the equation. Or you can say we went from 4 on the right side to 1/4 on the left side. So we flipped our number. And so that's exactly what they're trying to test here, is that when you divide by something, it flips on the other side. You can think of it like that. You can think of it like flipping. 4 became 1/4 because m over 4 is 1/4. So this entire algebraic part, this entire term, will now flip on the other side. And so which of the choices expresses that is B. Because A is simply this expression, but with two variables flipped, and you can't just flip the two variables without, like B shows, flipping everything else. Now number 8. If A over B equals 2, what is the value of 4B over A? And so we're given an equation, so I'm going to write it out. A over B equals 2. But the question wants the value of 4B over A, and we're given A over B. So since this question is wanting B over A, we can ignore the 4 for now. I'm more focused on the fact that it wants B over A, but gave us A over B. So we can rewrite our equation to show B over A. So I'm going to multiply by B on both sides, giving me A equals to B, and then divide by A on both sides. A divided by A is 1 equals 2B over A. And so now we have what B over A equals 2B over A, in our case, equals 1. But we're being asked for the value of 4B over A. So to make 2B over A equals a 4B over A, we just multiply our 2B over A times 2. So times 2 times 2, we get 2 equals 4B over A. So the answer is C. Number 9, what is the solution xy to the system of equations above? 3x plus 4y equals negative 23. 2y minus x equals negative 19. Okay, number 9. What is the solution x comma y to the system of equations above? Well, our system says 3x plus 4y equals negative 23. And 2y minus x equals negative 19. So there's two ways that you can solve any system of equations. One is either by substitution, or the other method is by elimination. And so since this variable here, this minus x, doesn't have a coefficient, or at least not one that's not either 1 or negative 1, you can think of it as being isolated, or we can make it isolated so that substitution works in our favor. So I'm going to rewrite this equation. So we have 2y minus x equals negative 19. I'm going to add x to both sides, so 2y equals x minus 19, and then add 19 to both sides, so we have 2y plus 19 equals x, and since this equals x, we can substitute this into our first equation. So we have 3 times 2y plus 19 plus 4y equals negative 23. So 6y plus 57 plus 4y equals negative 23. Subtract 57. Add like terms, we get 10y equals a negative 80. Dividing by 10, we get y equals a negative 8. And so we could, to get the x term, plug negative 8 into y for either of these two equations in our system, but we know that y equals negative 8. So let's look at our choices and see which ordered pairs don't show negative 8 for the y value. Well, A doesn't, C doesn't, and D doesn't. So this automatically tells us that B is our answer. Number 10, g of x equals ax squared plus 24. And so for the function g defined above, a is a constant and g of 4 equals 8. What is the value of g of negative 4? And so when solving equations, you might be plugging in values for x, and so it's important to be familiar with this notation. G, how you pronounce it, is g of 4. So g, or any variable with the parentheses next to the letter, means you're plugging in 4. So g of 4, meaning plug in 4 for x or whatever variable you are using, equals 8. So what that means is that with this equation above, when I plug in 4 for x, I'm going to get 8. So 8 must equal a, which we'll solve for right now, times plugging in 4 squared plus 24. So 8 equals 4 squared is 16 times a plus 24 minus 24 minus 24. We get negative 16 equals 16a. So a equals negative 1. That means that now we're going to plug that back into our original equation, which says that g, well, let's see, rather we need, so now we're trying to figure out what g of negative 4 equals. So we're going to plug in negative 4 for x, and so we have our negative 1 because of a times negative 4 squared plus 24, right? We're plugging in negative 4, so we have negative 4 squared is positive 16, but then times the negative 1 on the outside means negative 16 plus 24. That equals a positive 8. And so 10 is A. It's always important for questions like number 10 that you solve for the constant, because you can solve it other methods, but I prefer solving for constants to make the approach more systematic and not luck-based on an easier question. Number 11, b equals 2.35 plus 0.25x, and c equals 1.75 plus 0.40x, and so let's explore what these actually mean in context of our question. In the equations above, b and c represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? So the SAT will ask you, depending on the question, this is the one, to set values equal to each other. But they're going to try to hide it with their wording. So what was the price per pound of beef when it was equal to the price per pound of chicken? Well, the price per pound of beef and chicken is expressed by these variables. So by setting these two equations equal, we can figure out, we will eventually figure out what the price per pound of beef was when it was equal to the price per pound of chicken. So, as a good first rule, let's set them equal. So we have 2.35 plus 0.25x equals 1.75 plus 0.40x. Now, let's solve for x. Minus 1.75 minus 1.75. This is going to be 0.6 plus 0.25x equals 0.40x minus 0.25x from both sides. We get that 0.6 equals 0.15x. And so we can divide these without having to use a calculator, divided by 0.15. So how we do this is we have 0.6 divided by 0.15. With fractions, you can move the decimal places in the numerator and the denominator equally as far on top and bottom, and that maintains the equivalency of the fraction. So we can move the decimal on the denominator over 2 spaces, giving us 15, and 2 spaces on the top, 1, 2, giving us 60. So we have 60 divided by 15, which equals 4. But 4 is not one of our answers. That's because 4 is equal to x, and x is equal to the number of weeks after July 1st. So now we need to plug in what we may solve for x into our beef equation, because we're trying to find the price per pound of beef. And so we plug in 4, we get 2.35 plus 0.25 times 4, which is 2.35 plus 1, which equals 3.35. So 11 is D. We can erase some of this to give us room for the next problem. A line in the xy plane passes through the origin and has a slope of 1,7. Which of the following points lies on the line? So we can actually write the equation for this line to make it easier, because we're given by using point-slope form. So point-slope form, just to jog your memory, y minus y1 equals m times x minus x1. This one should be a subscript. So we need a slope and a point to find the equation, to write the equation of any line. And so we have a slope of our line, 1,7, and a point, because you know it passes through the origin. The origin is 0, 0. So with that, we have our point 0, 0, which we can label as x1, y1, and then plug into our formula. So y minus 0, or just y, you can write it out, y minus 0 equals the slope times x minus 0, or y equals 1 over 7x. Because it's 1/7 times x minus 0. And now, which of the following points lies on the line? To determine this, we can simply plug in all these points into our function, and if the equation makes sense, if we get two numbers that equal each other, then that point is on the line. So let's try plugging in, for example, the point for b. Well, if x is 1, then y is 7. So 7 must equal 1 over 7 times 1. Well, 7 does not equal 1/7, so it can't be b. Let's try plugging in d, for example. Well, here, let's give it some more room. If I plug in 14 for x and 2 for y, I get 2 equals 1 over 7 times 14. 14 times 1 divided by 7 is 2, so 2 equals 2. So this is correct. So 12 is D. For number 13, if x is greater than 3, which of the following is equivalent to 1 divided by 1 over x plus 2 plus 1 over x plus 3. So this is a very confusing looking expression, but to make it easier, we can set a value for x, since all we're told is that it's bigger than 3. So let's say x equals 4 for simplicity. If I plug in 4, I get 1 divided by 1 over 6 plus 1 over 7. And so 1/6 plus 1/7 is going to look like 7 over 42 plus 6 over 42 when we rewrite the two fractions. So we get 13 over 42. But this is 1 over 13 over 42. And so you can think of it like this. We have 1 divided by 13 over 42. Keep, switch, flip, 1 times 42 over 13. So that gives us 42 over 13 as what this expression equals when you plug in 4. So now all we have to do is plug in 4 into all 4 of these answer choices and look for 42 over 13. So let's plug it into the first one. 2 times 4 plus 5 divided by 4 squared plus 5 times 4 plus 6. Well, 2 times 4 is 8 plus 5 equals 13. 4 squared is 16 plus 5 times 4, 20. That's 36 plus 6 is 42. This looks very close, but it's flipped. And so it can't be A, but because we know that we need to flip this answer to get our target answer, we know that 13 must be B, because A and B are simply flipped forms of each other. Okay, number 14, if 3x minus y equals 12, what is the value of 8 to the x divided by 2 to the y? So let's quickly refresh our exponential rules. So if we have, let's say, for example, a to the 6th power divided by a to the 4th power, we're going to keep our base but subtract our exponents to give us a squared. And so same thing applies with this, but you have to have the same base. And so what the SAT is going to test you on is your ability to rewrite exponents with a different base using known like exponents. And so to most easily explain this, we can rewrite 8 by saying that 8 equals some number with a base of 2 raised to some exponent. We'll call it z. And so 2 to the what power equals 8? Well, 8 equals 2 cubed. And so we can rewrite our division problem as 2 cubed x divided by 2 to the y. And now this is power of a power, so since it's 2 cubed to the power of x, it'll be multiplying the powers. So 2 to the 3x divided by 2 to the y. We saw up above that it is 2 to the 3x minus y, and luckily we were given what 3x minus y equals, and that's 12. So all of this equals 2 to the 12. And so 14 is A. Okay, number 15, I'm going to have to give myself some more room. So it says if ax plus 2 times bx plus 7 equals 15x squared plus cx plus 14 for all values of x, and a plus b equals 8, what are the two possible values of c? So we can first like to write out. So we have 15x squared plus cx plus 14. And so whenever I'm given a factored form of a quadratic, like this for example, I find it useful to multiply it out or FOIL it out. FOIL, right? Have remembered this from your algebra class. So we have FOIL. So we have, I always find it useful just to multiply it out and see what happens. So ax plus 2 times bx plus 7. Well, we're going to multiply the first two terms, ax and the bx. So we have a bx squared. Multiply the outer two terms, or the ax and the 7, plus 7ax. The inner two terms, the 2 and the bx, plus 2bx. And then the last two terms, the 2 and the 7, to get plus 14. So we can now compare, because we know that ax plus 2 times bx plus 7 equals our 15x squared plus cx plus 14. We can write underneath it, put a bx squared plus 7ax plus 2bx plus 14. And so what looks familiar? Well, the plus 14 and the plus 14. But look at this, 15x squared and abx squared. What this is saying is that a times b equals 15. So we have a times b equals 15, and a plus b equals 8. So what two factors multiply to get to 15? Well, 3 and 5. And 3 and 5 makes sense because 3 plus 5 equals 8. So we know that a and b equal 3 and 5. And so with all of that, I'm going to free up some room. With knowing that a and b can equal 3 and 5, let's try to find values of c. Because we also know that cx equals 7a plus 2b, because these are the two terms with x's. So 7a plus 2b equals c. We can disregard the x because x is in all the terms. So plugging in, let's say, for example, 3 is a and b is 5. 7 times 3 plus 2 times 5 is 21 plus 10, which equals 31. And so just by looking at our choices, we can automatically tell that it's not A, B, or C, it has to be D. But just to double check, now let's say instead that A is 5 and B is 3. Well, 7 times 5 plus 2 times 3 is 35 plus 6 is 41. So we do get both values, 31 and 41. So now we're going into the filling in response questions where you write your own answer. You're not given choices, so these questions are usually going to be slightly easier than the last couple multiple choice questions. So number 16, let's see, here we go. If t is greater than 0 and t squared minus 4 equals 0, what is the value of t? Well, we have t squared minus 4 equals 0. I'm going to add 4 to both sides. And I'm going to square root, because it's t squared, so t equals the square root of 4, which is 2 or negative 2, but we are explicitly told that there will be no negative answers. No question has a negative answer. So, although we may get more than one answer, you must pick between the two, and in this case, there's no reason to pick negative 2 because you can't write negative numbers in the answer box, so the answer is 2. Number 17. Oh, can't see the top letter. Here we go, number 17. A summer camp counselor wants to find a length x in feet across a lake as represented in the sketch above. the lengths represented by AB, EB, BD, and CD on the sketch were determined to be 1,800 feet, 1,400 feet, 700, and 800 feet respectively. Segments AC and DE intersect at B, and angle AEB and angle CDB have the same measure. What is the value of X? So we're going to write down what values they just told us. So AB is the segment right here. It's equal to 1,800. EB is 1,400. BD is 700. And CD is 800. And so what we can tell automatically is that, so these angles right here, angle AEB equals angle CDB, since they told us. But also we can recognize using a vertical angle theorem that these angles are also equivalent because they are vertical angles, since they are opposite of each other, and they're formed by the intersection of two lines. We know that this triangle has angle-angle similarity, which means that all the lengths on this triangle equal, or are equal to, but let's repeat that. And so what that means is that all of the side lengths on this triangle are equal to the side lengths, or not equal to, are in proportion to the side lengths on this triangle. And so what's immediately obvious is that EB is 1,400, but BD is 700. So that tells us that the ratio between any side length on the small triangle is half of that on the big triangle. And so what we can use to determine AE is figure out what is the similar side length on triangle BDC. Well, because we pointed out our vertical angles right here are what open up to this side, and they also see how this angle here is pointing towards this side. That means that AE is proportional to DC. And since DC is 800, we know that all the side lengths on this bigger triangle are just side lengths on the small triangle times 2. We know that AE equals 1,600, or 800 times 2. So X equals 1,600. And now we have number 18. What is the system of equations, or according to the system of equations above, what is the value of X? And so, I stated before in our previous question that dealt with a system, there are two ways to solve it. You can either solve by substitution or by elimination. And so what we can do here is we can figure out which of the two methods we want to use. And so by looking, there are a lot of variables that are just by themselves, but it also wouldn't be very difficult to do it by elimination. I'm trying to figure out, we can do this one by, for example, substitution. So that first equation is X plus Y equals -9. Well, we can rewrite this so that X equals -9 minus Y, because we just subtract the Y. So we can plug in this into our second equation, getting -9 minus Y plus 2Y equals -25. Well, -Y plus Y is going to give us Y. I'm going to add 9 to both sides. So a -25 plus 9 is a -16. And so Y equals -16. So we can plug this into either one of our two equations, however it'll be easier in the first one. So we have x minus 16 equals negative 9. And add 16 to both sides. We get 16, negative 9 plus 16, so x equals 7. So number 19. In a right triangle, one angle measures x degrees, where sine of x equals 4 over 5. What is cosine 90 degrees minus x degrees? So since these are trig functions, we have sine, cosine. I'm going to draw a triangle. Big old triangle. Right triangle, since this is trigonometry. Since we're dealing with, since it tells us right triangle. And so we have sine of x equals 4 over 5. So let's say that this is x degrees. Whenever you have any triangle that's a right triangle, if one side is x degrees, the other side has to be 90 minus x degrees. And why is that? Well, because the total interior angles, the total sum of all the interior angles of a triangle is 180. Well, if we subtract the right angle, that's minus 90, that equals 90. And so if we know that one of our degrees is x, to find the other, we just do 90 minus x, because it's subtracting from our total left of 90. So now we can figure out, we can start putting down some numbers. So sine of x equals 4 over 5. And so what is sine? Well, we have SOHCAHTOA. So sine is opposite over hypotenuse. So 4 over 5 is opposite, because this is the angle that we're doing the sine for. Sine equals, let's give us some room, sine equals 4 over 5, so 4 over 5. And then we're going to figure out what is cosine. Or so first we established that this is 4, this is 5 based on our sine, because they gave us it. And now we are asked to find cosine of 90 degrees minus x degrees, which is this angle right here. Well, what's cosine? Cosine, as written here, is adjacent over hypotenuse. So if this is the angle, adjacent is the 4, hypotenuse is 5. So cosine of 90 degrees minus x degrees equals 4 over 5, or the same thing as our sine of x. So the answer here is 4 over 5. And so, number 20, the last question of the no calculator, if a equals 5 times the square root of 2, and 2a equals the square root of 2x, what's the value of x? Here, we can make this a little clearer. What is the value of x? Well, real simple, or a real simple explanation. Number 20, if a equals 5 times the square root of 2, and 2a equals the square root of 2x, what is the value of x? Well, if a equals 5 times radical 2, or the square root of 2, and 2a equals the square root of 2x, what is the value of x? Well, we can actually undo simplified radicals like this. For example, what if I have, for example, I have 2 square root of 2. This equals the square root of 8. But how? Well, if I square the number on the outside and then multiply that by the number on the inside, that gets me my unsimplified radical. So if I square 2, 2 squared is 4, times 2, which is the inside number, that equals 8. And so, given that, we can now figure out our question. And so, since a equals 5 times radical 2, and 2a equals square root of 2x. They want the value of x. Well, I'm going to first, since we have a and they want 2a, we know that a equals 5 times radical 2. But how do we get 2a from what we were given? Well, we can just multiply our equation by 2. So 2a equals 10 times radical 2. And you multiply by whole numbers, or by any number, you just multiply the number on the outside of the radical, not the radical itself. So 2a equals 10 times radical 2. And then we can undo this radical, because what we're given for 2a, there's nothing on the outside of the radical. It makes it easier on us. Remember, we square the outside number, and then multiply that by the number on the inside of the radical. So 10 squared is 100, times 2 is 200. So 2a equals square root of 200. So we know that 2a equals 2a. So the square root of 2x equals the square root of 200. So we can, since square root equals square root, we know that 2x equals 200. We're going to set equal to what's inside the radicals. Divide this by 2x equals 100. And so if you got any questions, please let me know in the comment section. That's it for section 3, no calculator. I will be continuing to make more videos on all the practice tests released by the College Board, all the section 3s, which is no calculator, and then eventually I will do the calculator sections. And so, thank you for watching. I hope this helped, and yep, you can find more tutorial videos just like this coming up soon.